Math 30s. This is going to be the first lesson in your transformations unit. One thing I always like to sort of tell students or warn students about at the beginning of this unit is that the concepts that you're going to learn in this unit, they will carry through in about 4 more chapters in this course. So I always tell students you need a really, really good understanding of this unit because if you struggle in this unit, you would struggle in those remaining units. The unit is on something called transformations and was actually first introduced to you in 20-1 when we did quadratics. Okay, so I'm going to sort of start with a quick review of something we did in 20-1. One thing that I just want to remind you is your notebook in these note packages, anything that I write, you need to follow along and write that down. It's going to be considered part of your notes. And anything that I highlight, I highly recommend you sort of pause my videos, highlight the things that I have highlighted as well. Okay, so in 20-1, what we dealt with is we dealt with 2 units on quadratics. And what a quadratic was, it's a function written in the form of y is equal to x squared, and that was a parabola, right? And then what we did with transformations in 20-1 is we took this parabola and we moved it up or we moved it down. So we translated it up, translated it down, we moved it left, we moved it right, we reflected it, and we even stretched it. So in 20-1, I want to give you the letters or the parameters that we used in that course. And then in 30-1, it's going to change slightly. So in 20-1, the formula was y is equal to a, x minus p, close brackets squared, plus q. And what happened was this Q value moved your graph up or down. And what that is called, if you have an up or a down move, that is called a vertical translation. Okay, so an up-down move is a vertical translation. The P value in Math 20-1 moved your graph to the left or to the right. A left or a right move is called a horizontal translation. Okay. Then we had an A value, and that had to do with your stretch factor. So it was a vertical stretch. And if the A value was negative in 20-1, what happened with a negative A value is your parabola was reflected in the x-axis, and we called that a vertical reflection. Okay, so those were what were the parameters, this A, P, and Q in 20-1. Here's what it's going to change to in 30-1. So in 30-1, it is going to be y is equal to a, open bracket, x minus h, close bracket squared, plus k. So in 30-1, we letters. Instead of P, we use H. That doesn't change anything. That is still going to be your left-right move, which is your horizontal translation. And instead of the Q value, we're going to now use a K value. That's going to be an up-down move, and that is going to be a vertical translation. A value does not change. That's your vertical stretch. If A is negative, it's a vertical reflection. Okay? So it says, in this unit, we'll develop an understanding of the effects of transformations. And those are operations which move your graph. The transformations which we're going to do in this class, they're called translations, which is left, right, up, down moves. Reflecting, this is reflecting in your x-axis, and then we're going to reflect in 30-1 in your y-axis, and then we're going to stretch the graph. So those are the 3 translations that you have to be very familiar with. Okay, so let's do the first transformation, which is called a translation. Okay, now a translation, these are our up-down, or they're going to be our left-right moves. Now, translations, if I go back over here, are going to involve my H value and my K value. So this lesson is going to exclusively be on the H and the K value. Okay. Okay, so a translation is a transformation which slides the figure the same distance in the same direction. Okay, so what we're going to look at now is we're going to start with examining the K value. So the K value is a vertical translation, and that's going to be up and down. Write down examining the K value. Okay, so let's look at the effects of the K value. So we're given a function, and our function is the absolute value of x. So I just want to write down y is equal to f of x. This is called a function. I'll just clean that up. So y is equal to f of x. My f of x, my function, is this absolute value of x. So if you punch that in on your calculator, go to y is equal to, I'll actually clear this out. The absolute value button is under math. Scroll over to numbers, number 1, absolute value of x, and hit enter. So this was a concept absolute value in 20-1. So that is what an absolute value function looks like. That's the graph of an absolute value function. Okay, so you illustrate that. So what we're going to do in this example is we're taking our function, so f of x is our function, that's the absolute value of x, and we're taking that function and we're adding 2 to it. So happens when we add 2 to our function. So now go to y is equal to, and let's take that absolute value of x and we add 2 to it. Hit graph. Our function moved from the vertex was at 0, 0. It moved up to 0, 2. So it was translated 2 units up. So now we're at 1, 2. And our new function is here. The shape of the graph did not change at all. It just was translated 2 units up. So my K value, this is K is equal to 2, and it went 2 units up. You could enter this in your calculator if you want to. This is going to be our function minus 3. So our function was this guy here, and now we're going to subtract 3. So that means our K value is minus 3. What that means is our graph is going to be vertically translated 3 units down. The shape of my graph does not change at all. It just took this graph here and it went 3 units down. Okay? B. The equation of y is equal to the absolute value of x plus 2, it can be rewritten in this way here. So what they are saying is they're basically saying what they've done is whenever they put a number next to your y value, from grade 10, we always said, okay, you want to isolate y, right? So how you would isolate y is add 2 to each side. And what we would get is y is equal to the absolute value of x plus 2. What you just need to realize is that is the exact same as y minus 2 is equal to the absolute value of x. So whether it's written this way or this way, what I hope you can see is my K value is the same. My K value is 2, right? Because if you isolate y from here, add that negative 2 to both sides, and our K value is 2. So if our K value is 2, what that means is it's a vertical translation 2 units up. Okay? The equation y is equal to the absolute value of x minus 3 can be rewritten as this. So again, let's take this equation. So y plus 3 is equal to the absolute value of x. That is the exact same as y is equal to the absolute value of x minus 3. And my K value, no matter if it's written here or if it's written here, whenever I think of the K value, I always like looking at the right-hand side because my K value is negative 3. So here, my K value is negative 3, and that's a vertical translation of 3 units down. Okay, what is the um, effect of parameter k on this function? So parameter k, we just did that in B and C. Parameter k, it's a vertical translation of k units. And this guy, it's the exact same thing, right? I always like isolating for y. So y is equal to whatever our function is plus k. That is a vertical translation of k units. Doesn't change. Okay, so comparing this to this results in, again, same thing over, a vertical translation of k units, because that's what the k parameter does. So if k is greater than 0, your graph moves up, right? And if k is less than 0, your graph moves down. What you need to be really good at in this course is you need to be good at this. If I give you y plus 4 is equal to f of x, you need to be able to just look at this in your mind and tell me, is that an up or a down move? And what you should be able to see is my k value. I hope everybody could see this. My k value is -4, right? Because I'd really bring it over there. And that's a vertical translation 4 units down. Okay. One thing I just like students to make note of down here is, even though most students like seeing this, f of x plus k, your book and tests are often going to write it like this: y minus k is equal to f of x. And the reason why they do that is they want the k value to be next to the y value. And what we're eventually going to see when we look at coordinates on graphs is the k value is actually a transformation on y. Oops, not of. It should be a transformation on y. So what is changing is my y coordinates on my graph. And if I just quickly show you, for example, this question, my vertex here was at 0, 0. This is my x coordinate and that's my y coordinate. When I went up 2, this point moved 2 up, and my new point is 0, comma 2. So this 0 changed to a 2. And then this point now is 0, comma -3. So the k parameter affects your y coordinates. So make sure that you feel really good and comfortable with that. Okay, so that is your h values, or sorry, your k values. Okay, turn to page 77 in your workbook. And what we're going to do now is we're going to look at the transformation on the h parameter, like what happens. I think what I've done is I do believe I've changed your workbook. So just check the 3 examples that your workbook uses and then change them, because you'll be able to more clearly see what happens from these 3 examples. Okay, y is equal to x squared. That's my new function, f of x, right? So y is equal to f of x, and my function could be anything I want. So in the last example, my function was the absolute value of x. In this example, my new function is going to be x squared. It's going to be a parabola. And you guys know from 20-1 that this is a parabola. Okay, so that is my diagram for y is equal to x squared. Then remember, I told you guys in 20-1 that this value is either going to move your graph left 1 or right 1. And a lot of students, when I said to guess in 20-1, a lot of you said, I think that's going to go left 1. And when we actually graphed it, so let's graph this. So y is equal to x squared. There's my parabola. And then when I change that and I put, so let's clear this, and let's hit open bracket, x minus 1. Let's close that bracket and square it. Okay. A lot of people think that minus 1 means it's going to go to the left one, but it actually is the opposite. And that instead of going to the left one, it actually went to the right one. So a few things that I need you to realize. If I said to you, okay, what is your H value here? And remember in 20-1, I would have just called it your P value. I would have said, well, what's your P value? So in 30-1, I'm going to say, well, what's your H value? It's always the opposite of what it appears in here. So the H value is not -1. The H value is actually 1. And remember that the H value is your horizontal translation, and a horizontal move is a left-right move. So if you have an H value of 1, what that means, it's going to be a horizontal translation of 1 unit right. Okay, so I put this picture in, like here's your x squared, and then here's your open bracket x minus 1 close bracket squared. Now, this guy here, what is your H value? The H value is not 4. The opposite of 4 is -4. That means that our new graph would be horizontally translated 4 units left. And our new graph would go from here, from 0, 1, 2, 3 here. And the shape would not change of my graph. It would just be translated 4 units left. Okay. One thing I want you to notice is what the transformation was we had y is equal to f of x, and then we are going to y is equal to f of x minus h. This transformation, it's what we call within the function. Okay. Because I took that bracket of x and I'm putting within that function that h value. When we did the k value, so y minus k is equal to the f of x, that k value is actually outside of the function. So the h value is within the function and the k value is outside of our function. Okay? Okay, part 2. So they give us this function here, y is equal to the absolute value, or sorry, the square root of x. Okay, so just I'll show you what that looks like, and we'll maybe even look on our calculator. This is the square root of x. That's the function for the square root of x. So y is equal to the square root of x, and graph that. Okay, so this line or this graph here, what's going to happen when within the function, right? I'm not outside of the function. If I was outside of the function, I would have this square root of x minus 4, and that would be a down move 4. This is within the function. So within the function, you have to say to yourself, okay, I'm within the function. That's my h value, right? H is always next to the x value. So my h value would be the opposite, which is 4. That's a horizontal translation, 4 units right. 1, 2, 3, 4. My translated graph would go here. And again, I'll prove it. So y is equal to, go within your function, and square root of x minus 4 takes that graph and it translated it 1, 2, 3, 4 units right. Okay, what would this guy do? It's within the function, that's an h value. Your h value is equal to -2, not 2. -2 is a horizontal translation, 2 units left. That graph would go 1, 2, and it would be here. Okay? So again, your h value is your horizontal translation. So y is equal to f of x. That graph compared to now putting an h value within the function results in a horizontal translation of h units. If h is greater than 0, your graph moves right. So again, y is equal to f of x minus 5. That is an h value of 5. That graph would go 5 units right. If h is less than 0, y is equal to whatever my function is, and let's put in x plus 3. My h value is negative 3. That would be less than 0. That would move down. Or sorry, that would move left. That would be a left move. Okay, flip to page 78. We're going to talk about replacement notation and mapping notation. And actually, before we even do that, the bottom of page 77, I want you to add something. Okay, so what we're going to be doing when we move points is we're going to be what's called mapping our points. So I'm going to give you a point and then we're going to map it to a different location. So if I say a point moves 1 unit up and 3 units left, what you have to be able to see from this is you have to be able to say to yourself, okay, so what I've taught you so far is y is equal to f of x minus h plus k. And you know that this is your horizontal translation and this is your vertical translation, right? This is what we've done. So if I say a point moves 1 unit up, is that a k value or an h value? And I hope you are good now. 1 unit up is a k value, and my k value would be equal to 1. And then 3 units left. So if I said, okay, well, what would 3 units left be? That's your h value. H is equal to negative 3, right? 3 units left would be f of x plus 3. And then 1 unit up would be plus 1. Y is equal to. Okay, so this would be a function that moves 1 unit up and 3 units to the left. Now, if we're mapping, what's going to happen is I'll give you a coordinate. So x comma y would be your coordinate. And then you're going to have to move your coordinate 1 unit up and 3 units left. Now, the up value, 1 unit up, remember that's your y coordinate. And your 3 units left affects your x coordinate. Okay, so if we were mapping, how you map this is essentially the following. You take your x value and you add whatever your h value is. And then you take your y value and you add your k value. Because your k value affects your y coordinate and your h value affects your x coordinate. So what this would be mapped, 1 unit up and 3 units left, would be x plus h, and h is negative 3. So that would be x minus 3, and then y plus k is 1. Okay? So again, if I gave you a coordinate, and let's say I said, okay, your coordinate was 3, 6 on the original graph. Well, what would happen to this coordinate at 3, 6 if it went 3 units left and 1 unit up? 1 unit up, that 6 would go to a 7, right? 1 unit up, that 6 would go to a 7. And 3 units left, that 3 would go to a 0. My new point would be at 0, 7. So we'll do a couple of these questions more, but you sort of, this is what you need to be able to understand. Okay, let's look. So we haven't even gotten to actually the class examples yet, but let's get into the class examples. And something called replacement notation. Okay, so what happens to the graph of this function when the following changes are made to its equation? So what they want me to do is they want me to replace x with x plus 2. Okay, so let's see what happens. We're given y is equal to f of x. And what they want me to do to this is they want me to take out this x and they want me to replace it with an x plus 2. So that would be f of x plus 2. When I replace this, did I just do a vertical or a horizontal move? So what you need to be able to see is, okay, this is within my function. That is an h parameter. So h is equal to -2, and that is a horizontal translation, 2 units left. Okay, let's look at B. Replace y with y minus 8. So here is the graph of our function. Y is equal to f of x. What they want me to do is they want me to take out my y. So this guy comes out and they want me to put in y minus 8. Okay, now when you get really good at this, I need you to just be able to look at this and say to yourself, that's a k value. The k value is 8. And that k value of 8 is going to be a vertical translation, because it's an up-down move, of 8 units up. Some students, until they get good at this, will need to isolate their y, right? And they'll need to say, okay, I got to get rid of that -8. I've got to add 8 to both sides. Y is equal to f of x, which is our function, plus 8, right? That's my k value, which is a vertical translation, 8 units up. Okay, so that's what replacement notation is. Describe how the graphs of the following functions relate to this. Okay, so this guy here, that's my h value. H is equal to 3. If it's an h value, that is going to be is that vertical or horizontal? And you'd say that's a horizontal translation, 3 units right. This is a k value. K is equal to 4. Vertical translation, 4 units left. 2 transformations are happening here. This guy is an h value of -10. Okay, h value of -10 is a horizontal translation, 10 units left. This is your k value. And again, I'm not going to move that y because I just want you to be able to, you need to be able to look at this and see what it is. My k value is equal to 1. That is going to be a vertical translation, 1 unit up. Okay. Okay, let's do some mapping now. Now, remember that mapping, how I said it works, is we have our coordinate, and the h value goes with the x, and the y value, or the k value goes with the y. Okay, so that's how we map. So in this first question, I get, they give me this coordinate here. So they're saying this point lies on the original graph. State the coordinate of its image. So the image is after it's undergone a transformation. So when I take 2, -3, and it undergoes this transformation, what will this new point be, is what it's asking. Okay, so how do we do that? First, we need to say, was this an h value or a k value? That's a k value. And that is going to be k is equal to -8. Because remember, always picture your k value on the right-hand side. So k is equal to -8. That's a vertical translation, 8 units down. Now, the k value affects your y coordinate, right? The k value affects your y coordinate. So this point, so I'll just sort of show you. So x is at 2, y is at -3. So that's my point there. What's the new point when this goes 8 units down? Okay, so what would that new point be? So I always like you to show me here's how I want you to write it. So our original point is 2, -3. Then we have to, there's no h value, so our x stays the same, and our y, it's going to be plus k, and our k is -8, right? So that would be our x value stays the same, and our y value, which is -3, I bring it down 8. So my new coordinate, when I take this and I go 8 units down, it is going to be at 2, -11. That is your answer. Okay. Now, let's see if we could do this one. So take that coordinate, 2, -3. So let's write that down, 2, -3. They want us to take that and go 5 up. So our k value is 5. So k is equal to 5. And we know that if k is equal to 5, that's our vertical translation 5 units up, right? Here's our h value. H is equal to 7. That's a horizontal translation, 7 units left. So you take your point, and it's going to be translated to x plus h, y plus k. So I take my point, and my point was 2, -3, and 2, and now I got to do my h value. So my h value is plus 7. So it's going to go right 7. This point will go right 7. And then you take your y value, which is -3, and I got to put my k value with it. My k is 5 plus 5. So that point is going to go, it's this point here, 2, -3. It's going to go to the right 7, and then it's going to go up 5. And where does that take us? So 2 plus 7 is 9, and that is 2. 9, 2 would be our answer. Okay. Class example number 4. Write the equation of the image after each transformation. Okay, so horizontal translation of 5 units left. H is equal to -5. Okay, so H is equal to -5. That would be Y is equal to F. Horizontal is within the function. It would be X plus 5. So remember that a horizontal translation, we always write the opposite in here. If it's going 5 units left within our equation, it's X plus 5. So that would be your answer for A. Your answer for B, a transformation or translation of 3 units up. Up is your K value. So we have Y is equal to F of X. And we're going to take that, and it's going to be transformed to Y is equal to F of X plus 3. That would be your answer for B. A translation of M units right. So a left-right move is our H value. And if we're going right, it would be positive M there. And P units down, that would be my K value. And K would be minus P because we're going down. Okay, so now I've got to take my original equation, F of X, and I need to make these transformations. So M units right, that's within the transformation. So that's going to be Y is equal to F of X minus M, right? Because if I want to go to the right, this would be a minus. We do the opposite. And then I want to go down. So I'm going to put minus P. That will move me down. This is acceptable as an answer, Or students who are really, really good at thinking about this, they know that that k value over here can go with the y because it's the transformation on y. So some students on a test will take it one step further and they will say this is actually the answer, and they are correct, right? Because this is a transformation of m units right and p units down. Okay, question number 5. I'm only going to do B here. Um, okay, so it says, given the graph of the function y is equal to f of x, sketch the graph of the indicated function. So these are points on my graph, right? And they want us to undergo these two transformations. So you need to be able to look at this and you need to be able to say, okay, that's my k value. And what is the k value? So the k value is equal to -2, right? So just remember, always picture the y by itself and bring that 2 over there if you need to. And negative k is equal to -2. That's a vertical translation 2 units down. So each point is going to go 2 units down. Then the other thing we're going to do is we're going to do another translation, and that's our h value. The h is not 3, it is actually -3. So my h value is -3. That's a horizontal translation, 3 units left. Okay, so what do? We take a point. Now I have terrible eyes, so you guys will be better at this than me. But you take a point and you have to move that 3 units left, 2 units down. So 3 left, 1, 2, 3, 2 down. It's right around there. This guy, 3 units left, 1, 2, 3, 2 down, would go right about here. This point, 3 units left, 1, 2, 3, 2 down is right about there. This guy, if I went 3 units left, 2 units down, 1, 2, 3 would be about here. And then this last point, 3 units left, 1, 2, 3, and 2 units down would be about there. Okay, then you'll get a ruler. And you will join your coordinates. So that would be your transformed graph of moving 3 units right and 2 units down. Now, something I want to show you, because for sure this is going to be a quiz question. Like you guys will have that quiz your first week back, and I'll give you, this will be a quiz question. Okay, what they like asking is how did the domain change from this function to the new function? So I'm going to show you a few things. So you need to be really good at writing domain and range. So first of all, my domain of my original function, I'll do it in blue, okay? So my domain was from, this is my biggest x, and that's my smallest. So from 9 to -5. So my domain, how one way you could write it is the following. It's called set notation. So x is less than or equal to 9, greater than or equal to -5. On tests, though, and on your diploma and on your unit exam, they will rarely want anything in set notation. They will want this written in interval notation. So what this domain really is, the smallest x value is -5, and the biggest x value is 9. So that is the domain of my graph, okay, of my original graph. If I said, okay, what's the range of the original graph in interval notation? Range has to do with your y values and the biggest y value to the smallest y value. So my biggest y value is 6 on my original graph, and my smallest y value is -3. So my biggest y value is 6, and my smallest y value is -3. That's the range. My y's are less than 6, greater than -3. Okay, now what you need to be able to do, and on a test, I won't even give you this picture, but if I said, okay, this was the domain of and range of your original graph, what's the domain and range of your new graph that's been transformed 2 units down and 3 units left? So what you need to remember is that your H value affects your domain. It affects your domain. So my new domain is, these are my X values from my domain. So my new domain, you guys, is subtracting 3 from each of these numbers because the H values affect the X on your domain. So my new domain, or my transformed domain, is -8, comma 6, right? So this guy here goes from -8 to 6. Now, the K value affects your range. It always affects your Y values, which is your range. So that -2, I apply to my Y values on my range. So this would be -3 minus 2 and 6 minus 2. My new range is -5. 6 minus 2 is 4. So my new range of this green graph here should be -5 is my smallest Y value, to 4 is my biggest Y value. So you really, really need to sort of see that and understand that your domain is your X values, and that's affected by your H parameter, your range is your Y values, and the K affects your Ys. Okay, let's do question 6, and then let's do question 6, and then I will do one question from your homework. So question 6 is the last one. Okay, so what we have is um, okay, state the coordinates of the image of the point under the translation described. Okay, so they give us an original point, and that's going to be this coordinate here, and then they want it to undergo this transformation here. Okay, so a few things that we need to see is that this is our H value, right? So H is equal to -7, and that is a horizontal translation, 7 units left. That's our K value. Our K is equal to 4, and that's a vertical translation, 4 units up. Okay, so we've got those two transformations. So we have X comma Y, and our X comma Y, I should actually just write it. It's -3, 5. And then it's going to be -3 minus 7, right? So we're taking our X coordinate, which is -3, and we're going to go 7 units left. So that's where we put in whatever H value is, -7. And then we take our Y value, which is 5. And what are we doing to the Y value? We're moving it up 4. So we're going to add our K value, and K is 4. So our transformed point is going to be -3 minus 7, which is -10, and 5 plus 4 is 9. That's the image of our transformed point. Okay, let's do B. Okay, so let's do B. Write the equation of the image. Okay, so we're not actually given a point for this one. So what we're given is we're going to be given this equation here. And what's the new equation going to be after it undergoes this translation? So what you should see is that, remember, is your H value. So h is equal to negative 6, which is a horizontal translation, 6 units left. Okay, horizontal translation, 6 units left. Um, this is our k value. K is equal to 1. Vertical translation, 1 unit up. Okay, so let's write this. Y is equal to f of x is our original equation. And then when it undergoes these transformations, this guy, 6 units left, would be f of x plus 6, right? 6 units left. Remember, for h parameter, we always do the opposite. So that would be 6 units left. And then k value of 1 would be plus 1. And then from here, you could give that as an answer. I would fully accept that. Or what's even better probably is y minus 1 is equal to f of x plus 6, because that tells me that my k value is 1 and my h value is negative 6. Okay? For your homework, I want you to do all 10 questions. Make sure when you're doing your homework that on the Google Classroom, you can open up the worked out solutions. So I will upload the teacher's manual, so the completely worked out solutions for you. So make sure that you have that as you're doing your homework. The one question I'm going to do with you, so is this question number 8. So if you want, what I would do is I'd probably pause this, do all the questions, and then number 8, when you get to it, I'd probably watch it. 8 would be the challenge question, and I always like putting this on the quiz as well. Okay, so here's number 8. So let's do this guy together. What it says, the function y is equal to f of x is transformed to this guy here. So y minus 3 is equal to f x minus 1. So we know, just looking at this, right? Just looking at this, you know that the transformation, that's your k value. K is equal to 3, and that was up 3. So vertical translation, 3 units up. This is your h value. H is equal to 1. Horizontal translation, sorry, not 3, 1 unit right. Okay, so k is equal to 3, h is equal to 1. Then what they do is they give us this point here, but we haven't done a question like this because it's normally what we've done is that's the original point, and then we transform it, which is really easy, right? We would just take the y value, go up 3, take the x value, go left, or sorry, go right 1. But what they're saying is this point lies on the graph of this. So this point lies on the transformed graph. So that point of negative 2 comma 4 lies on the transformed graph. And what they want to know is what was the original point. So how you do this is, I always think the opposite, right? So to go from here to here, we went up 3, right? So to go from here to here, we went up 3. So what's the opposite of going up 3? If we went up 3 to go this way, so I'll just go like this. This is up 3. Going this way would be down 3. And that affects your y value. So it would be 4 minus 3. Our new y coordinate would be at 1. Okay, now to go from here to here, we went to the right one, right? So it told us to go to the right one. So to go from here to here, we went right 1. What would be the opposite of going to the right one? If I take this point, so from here to here, I went to the right one. From here to here, I need to go to the left one. So the opposite of going to the right one is going to the left one. So you take your x value and you're going to subtract 1, right? Because if you're at negative 2 comma 4. 1, 2, 3, 4. That's our point. And instead of going up 3, we're going to take this guy and we're going to go down 3. So 4 minus 3 is going to take us to 1. And then we're going to go left 1. Negative 2 minus 1 will give us negative 3. So our new point is negative 3, comma 1. And your answer is D.